So this one is what paper? This is W18-13. Starting with the first question. The first question is the first four ionization energies for element X are shown. So, which ion of X is produced by removing an electron from a filled subshell? As a question is slightly, one of the wording is slightly complicated. पहले तो ये बताओ कि which, by looking at the ionization energies, how many electrons are in the valence shell? कितने valence shell में? How many electrons in the valence shell? How do you figure that out? The pella electron, you're removing the first electron. It's kind of easy. You're removing the second electron, still easy. Removing the third electron, still kind of easy. Removing the fourth electron, that all of a sudden becomes difficult. So what does that indicate? Okay, outermost shell mein kitne electrons there? The first three, right? Because the fourth electron kind of belongs to an inner shell that is closer to the nucleus. Is that clear?
Yes, sir.
So it's got 3 electrons in the outer shell. Okay, so it's got 3 electrons in the outer shell. So which elements have 3 electrons in the outer shell? It's these elements. It's group 3 elements. Okay, so we are talking about group 3 elements. I don't know which element it is, but it is a group 3 elements. 3 valence electrons, right? Acha, so what is the electronic configuration of a group 3 element? The electronic configuration of group 1 element is S1. The electronic configuration of the group 2 element is S2. The electronic configuration of a group 3 element, any group 3 element, is S2P1. किसी को भी उठाओ उसकी लिख लो. Aluminium की लिखो 13 electrons. 13 electrons would be 1s2, 2s2, 2p6, 3s2, 3p1. So the outermost is always going to be S2p1. ठीक है, ये भी clear है कि if it's a group 3 element, coming here. If it's a group 3 element, its outer electronic configuration would be S2p1, right? So the question is, which ion of X is produced by removing an electron from a filled subshell? So ये X है. That's the electronic configuration of X, the outermost shell. Removing the first electron, you remove the first electron, it becomes X plus 1, right? So that was not removed from a filled subshell. Filled shell se to remove nahi hua tha. P has 6 electrons. That wasn't a filled subshell. दूसरे का कौन सा ion produce हो रहा है? X produced by removing electron from a filled subshell. The next one. Now you're going to remove the next electron from S2. That is being removed from a filled subshell. If I remove that electron, so there would be 1 left, and this would become plus 2. So the answer is going to be B. If this ion is formed when you remove an electron from a filled subshell. Clear question? Sign clear? Mahad, Alisha, is this clear?
Yes, sir.
सिर्फ वर्डिंग, हाँ जी, सिर्फ वर्डिंग confusion थी कि I mean actually काफी confusion थी. It was very hard to interpret this question. वो तो आसान था कि it's group 3. So you know okay, it's 3 electrons. Then you had to figure out that if it's got 3 electrons in its outer shell, that must be a group 3 element. A group 3 element always has, in the outermost shell, the orbitals are always S2P1. So the ion that will be formed by removing electrons from a filled subshell would be plus 2 ion. Plus 1 form karne ke liye, you're removing it from P1. So what is the basic assumption of kinetic theory as applied to an ideal gas? So ideal gas ki na bahut se assumptions hai. First one, collisions between gas molecules are elastic. I mean that is true. Okay, that is the correct assumption. Each gas molecules occupies a finite volume. That is wrong. उसका volume change होता रहेगा. ठीक है? Gases can expand and they can be contracted. Gases consist of particles that experience the force of gravity. Gravity has nothing to do with ideal gas. Gas molecules attract each other with weak intermolecular forces. What is basic assumption of the kinetic theory? Attract each other with weak. ये देखना पड़ेगा क्योंकि attract each other. I said, no main assumptions. Let me just go through ideal gases. There are two main assumptions. One is that they have negligible intermolecular forces. That is one of the main assumptions. The second assumption is that they have their volume. The volume of the particles itself is negligible compared to the volume that the gas occupies. Like whenever you have a gas, the gases where particles are far apart. So when you talk about the volume of a gas, it's mostly empty spaces. The particle itself, they don't have much of a volume. So the volume that they're occupying, the volume of the particles is negligible compared to the volume that they end up occupying. अच्छा ये दो main assumptions थी. And then there were a lot of smaller assumptions that were not actually the basic assumptions. कि अगर मैं वैसे गूगल कर लेता आ जाएगा assumptions of ideal gases. उसमें इलास्टिक कोलिजन्स टेम्परेचर का है, ठीक है, वो सारा है. तो तो इसको खोल लेते हैं. बल्कि मेरे पास नोट्स होंगे, तो छोड़ो. अच्छा, this one. सही वाला बोलते हैं, लिख ही लेता हूँ मैं, ठीक है, उससे बेहतर लिख लूँ. चलो हैक हो गया, just hold on a second. अच्छा, these were the two main assumptions. ठीक है, and then there are lots of minor assumptions which are okay, the collisions are elastic, right? The perfect rigid spheres. The molecules, they behave as perfect rigid spheres. There's one more assumption that that temperature is proportional to kinetic energy. ठीक है. Pressure is exerted when the gas molecules collide randomly with the walls of the container. So all of those assumptions, but these are the two main assumptions. In this case, he's saying that gas molecules attract each other with weak intermolecular forces. So assumption ये कि they have negligible intermolecular forces. And this one is also कि the collisions are elastic. ये भी देखना पड़ेगा कि is he talking about the main assumption? This is question number 2, and that is A. So I think D के साथ जो problem है ना वो ये कि the assumption is कि it's negligible. They don't attract each other. So that is why I think the wording is slightly confusing for D. कि the assumption about ideal gases is that they don't attract each other. ठीक है, negligible attraction है. ये clear ये बात?
Yes, sir.
और मेरे ख्याल से the reason it's wrong is कि weak तो ठीक था लेकिन attract, the assumption is they don't attract each other. So anyways, next one, you've got this reaction. He's saying a sample of C6H12 is completely burned. अच्छा, इसका answer ये कि if you burn C6H12, so the amount of carbon dioxide that would be produced and the amount of H2O would be produced would be in the same ratio. If you burn C6H12, 6 carbon dioxide molecules would be produced. And if you balance this, 12 hydrogen, so there should be 6 water molecules produced. So they would be produced in equal ratio. तो वो कह रहा है कि यहाँ पे there's carbon dioxide being absorbed, there's water being absorbed. They're both being produced in the same ratio. So if one water molecule is absorbed at the same time, one carbon dioxide molecule would also be absorbed because they're getting produced in exactly the same ratio. So Singha, what is the ratio? The increase in mass of the collecting vessel. So if a water molecule is absorbed, the mass increases by 18. If a carbon dioxide molecule is absorbed, the mass increases by 44 because that's the amount of carbon dioxide. So P की mass किससे increase हो रही है? 18 से, right? P increases by 18 and Q increases by 44. ठीक है? They both produce in the same ratio. So what do you get? 18 divided by 44. Whatever you're going to get, that's going to be your answer. Okay, if you have a calculator. किसी पास है calculator? What's the answer for this? What is 18 divided by 44? Sign क्या होगा?
Sir, it's coming 0.409.
ठीक है. So 0.41. Next one. 5 gram samples of barium carbonate, carbonates of barium, copper, lithium, and magnesium are decomposed for metal oxides and carbon dioxide. For which compound is there the greatest loss in mass? Now, this one is a difficult question because you have to solve for each one of them. You've got barium carbonate, and you have to oxide burn and carbon dioxide. You've got copper carbonate, so it's going to form copper oxide and carbon dioxide. You've got lithium carbonate. Now lithium is group 1, so उसने क्या कि oxide बन रहा है, that's Li2O plus carbon dioxide. And you've got magnesium carbonate, and it would form magnesium oxide plus carbon dioxide. अच्छा, इसके अंदर ना, what you can do is every time the equation is kind of the same. इसको देख लो कि is this balanced properly? Lithium is Li plus 1, CO3 is minus 2, Li is plus 1. So equation has the same ratio. तो सारों के अगर 5 gram sample होंगे, the trick is not to solve for each one separately. क्योंकि फिर तो टाइम बहुत लगेगा कि 5 gram sample है, इसके moles figure out करो, find the moles of carbon dioxide, figure out how much carbon dioxide is lost, and do this for every one of them. तो हमने देखा है कि who loses the most carbon dioxide? So who's going to give you the most moles of carbon dioxide? So how do you find moles? Moles is mass divided by mR, right? तो मुझे बताओ कि moles ज़्यादा कब आएंगे? When do you get more moles of this? When the mR is big or small?
Small.
Small. तो उसका मतलब है इसके moles ज़्यादा आएंगे. इसके moles अगर ज़्यादा आएंगे तो carbon dioxide moles would also be greater as well, right? By default. So the mR small. Barium is 137. Copper, I think, is 63.5. But I'm not even going to calculate the amount of CO3. That's always the same. Magnesium is 24. Lithium kya hota hai? I think that's what lithium is. 7. Lithium is 7, 6.9. So 7 ka leta hai. It's 7. So 7 and there are 2 lithium. So that's 7 into that. That's going to be 14, right? So the least MR would be for this one. So जब आप इसकी mass divided by MR करोगे ना, you'll get the most moles for this. You'll get the most moles of this, and the amount of carbon dioxide that would be produced would also have the highest moles. So the answer would be C. Okay, so remember, I did not solve the moles question. I saved time. I could have found moles for each one of them. Then I would have found the moles of carbon dioxide, and then I would have found the mass. Because mass calculator ne kya tha. But I figured out that the greatest loss in mass would be for the one that has the greatest moles. And who has the greatest moles? The one that has the least MR. Is that clear? इसको check भी कर लेते हैं. ये समझ आया question? Simon, Alicia, is this clear?
Yes, sir.
इसको से देख लेते हैं कि गलती ना हो जाए क्योंकि हमने solve तो किया नहीं है. 4 का C आ रहा है. That is C. Okay. So remember, a lot of questions you're going to, because remember you're always running out of time. Okay? A lot of questions will be solved without actually solving them. Okay? You have to make intelligent guesses. In this equation, you should assume methane behaves as an ideal gas. The gas loss can be summarized. What is the ideal gas equation? It's PV equal to nRT. But the only thing you have to be careful about PV equal to nRT is that the pressure has to be in pascals. The volume has to be in meter cube. The temperature has to be in kelvins, and N is moles. So you have to be careful about the units. So I'm going to use PV equal energy to find the mass of methane. So P is given, that is given as 103 kilopascals. I'm going to take that as 103,000 pascals. Volume is given as, it's already given in meter cube, so let's keep that 5.37 times 10 power minus 3. Acha, moles, R kya hota hai? That's 8.31. And what's the temperature? That's 60 centigrade. How do you convert that into Kelvins? That's 60 plus 273. So what do you get? That's 333. अच्छा इसके moles बता दो कि क्या आ रहे हैं moles इसके. What do you get for this? Correct कोई?
Zero point zero one nine.
0.2 हो गया ना? 0.199. अच्छा 0.2 moles, right? So you got 0.2 moles. He's asking for the mass of methane. So you have the moles. What is moles? Moles is mass divided by mR. So mass divided by mR. So multiply kar do mR se. That will give you mass. The mR of methane CH4, that's 16. So multiply that by 16. That will give you what? 16 into 0.2. What is 16 into 0.2? 16 times 0.2. C?
Yes.
C is the answer. So remember, PVC energy main thing, just remember this. What units to use. Here's enthalpy of combustion. This is MC delta T question, I think. So this one is a butane burner is used to heat water. The amount of butane is 58. So delta HC of butane. So butane burner, there's butane, which is burning, right? And it's producing heat. So there's a butane burner, it's produced and it's heating water. There's water on the top, and there is 250 grams of water. As 250 grams of water, and the water temperature delta T is 12 to, so delta T is given, that's 12 to 100, that's 88, right? And the burner transfer, so first thing is MC delta T. You can figure out the energy that is absorbed by water, the heat that goes into water, that's MC delta T. So it's 250 grams of water. The specific heat capacity of water is, I mean, it's given in the data booklet, that's 4.18. And delta T is 88. And remember, it's an exothermic reaction. It's when the temperature rises, it's an exothermic. Put a minus sign over there. So what do we get for this? This would be 250 into 4.18 into 88, right? So that I think is minus 91. Did anyone do this? It's 250, 4.18. I think that's 960, 91. I think that's 91960. So it's you check color, confirm color, that's kilojoules, right? That's joules actually. So that is the amount of heat that is being absorbed by water. But then he says something else, that this is only 47% of the heat. So only 47% of the heat that butane produces actually goes into the water. So this is just 47% of the heat. So you can use ratio 91960 kilojoules is, joules. So what is 100% of the heat that the burner produces? That would be X. So you would have to divide by 47 into 100. So divide by 47. And that comes out to be 195 and 660, I think. So this is the heat that is being produced by the butane. You clear? Is this
Yes,
clear?
sir.
But the question doesn't end here. The next part of the question is, what is the mass of butane? Now they gave us the enthalpy of combustion of butane. So now starts a separate question, which is, you've figured this out, right? And I need to convert that into kilojoules, so it's going to be 195 kilojoules, right? So the enthalpy of combustion of butane, what does that information tell you? It tells you that minus 2877 kilojoules of butane is energy is produced when how much butane burns per mole. That means 1 mole of butane. What's the mass of 1 mole of butane? Butane is C4H10, I think. So 1 mole of butane has a mass of 48. 12 into 4, that's 48. So 58 grams, right? 1 mole. You be clear? Is this part clear? That 2877 kilojoules of energy is produced when 1 mole of butane burns. 1 mole of butane
Yes, sir.
is equal to 58 grams. So it produces this much. So what is our butane producing? That's producing 195.66, right? So when it produces 195.66 kilojoules of energy, so I'm going to use ratio. What is the mass of butane that's going to be burning? Because I know that 58 grams produces this much. So how many grams would produce this much? So it's going to be 58 into 195.66. Just a second, 58 into 195.66. And then it's going to be divided by 2877. Which comes out to be C. Okay, so this one is a slightly lengthier question. Okay, like, clear? Is this question clear? And there's no
Yes, sir.
there's no shortcut for this. No, I mean, it's pretty hard to actually find a shortcut for this. You would have to do all of this. Okay, Bahal clear hai? Time. Also, is this clear? Alicia clear hai? Achha. Okay, so the next one you've got nitric acid is known to take. So this is easy, which will correct changes in oxidation number. SO2, that's oxygen is -2, so S would be +4. HNO3 की बता दो कि HNO3. How do you find oxidation states? तो यहाँ पे time बचाओ. H is +1, N is X, O is -2 times 3. Everything should add up to be equal to 0. It's a neutral molecule. X comes out to be +5. So N is +5. NO +1, oxygen is -2. So how do you get +1? N must be +3. And HSO4 -1. HSO4 -1. So H is +1. Sulfur is not known. -2 times 4. Everything should add up to be equal to -1. If you do this, X would come out to be +6, I think. So it comes out to be +6. The question was which row shows the correct changes in oxidation numbers? N goes from +5 to +3, so that's -2. And sulfur goes from +4 to +6, so that's +2. So the answer is B. I said next one. A transition metal ion M2 plus reacts with this thing and H2O, which equation correctly represents this reaction. So whenever you have a redox reaction, electrons gained and electrons lost must be equal. They have to be equal. So I'm just going to figure out which one is the correctly balanced equation. The first thing is the number of electrons lost and gained, they must be equal. So M2 plus to M4 plus, that is a loss of 2 electrons. So that is a loss of 2 electrons. What about the other one? Chromium over here is +6 to +3. So +6 to +3. that is a gain of 3 electrons. Ligand times 2 because there are 2 chromiums. So you can clearly see that the equation is not balanced. 3 electrons being gained and 2 electrons being lost. 6 electrons being gained. Mn जो होने चाहिए वो 3 होने चाहिए. So the answer would be C. I mean, this should be multiplied by 3. So the answer would be C. Is that clear? That the only way that the electrons lost and the electrons gained are equal is if you multiply this by 3. So there should be 3 M, sorry, there's no M in this M. Is this clear? So the answer C is correct. So the next one is equilibrium. Which statement must be true for Kp of this equilibrium to be constant? So when is Kp constant? Kp is only constant when temperature is constant. Sorry, Kp is only constant when temperature is constant. Remember, Kp value does not change. Pressure jo marzi ho. You increase pressure, decrease pressure, Kp remains a constant. So Kp is not dependent on the pressure. It always is a constant. Kp is not dependent on the external pressure. Which statement must be true for Kp of this equilibrium to be constant? In this question, ये C के ऊपर मुझे issue है. So if you want Kp to be constant, the Kp only changes with temperature, so it has to be temperature. Is C की मुझे समझ नहीं आ रही कि what does that indicate? Because you can't calculate Kp in the first place if the reaction has stopped. Kp is only for equilibrium, and at equilibrium, the rate of forward reaction, backward reaction is equal. So अगले पे आ जाते हैं. इसको ऐसे देख लेते हैं कि is this 9 should be D. It is D. Just remember, all equilibrium constants, they only change with temperature. That's it. So if you want to keep them constant, you have to keep the temperature constant. बाकी जो मर्जी करो, Kp पे कोई फर्क नहीं पड़ेगा. अच्छा, we have to calculate, I think, Kc in this 0.2 moles of sulfur dioxide. So इसके लिए you have to make a table. So 2SO2 plus O2 in equilibrium with 2SO3. Initial moles, final moles, ठीक है. Initial, what are the initial moles? 0.2 moles of sulfur dioxide. So इसके 0.2 और इसके 0.2. They're mixed, placed in a 1 cube vessel, and so this is 0. At equilibrium, there's 0.1 moles. So equilibrium पे जब देखा है, so they found that equilibrium, this is 0.1 moles of SO3. So this is 0.1 moles. So what does that mean? Okay, शुरू में तो ये डाले थे, and now at equilibrium you have 0.1 moles. So that means okay, at the beginning you didn't have anything, now you have 0.1 moles. So that means 0.1 moles got produced. That means there must have been some forward reaction, and 0.1 moles got produced. So to produce 0.1 moles, 0.1 moles of SO2 must have reacted, because it's 1:1. So if you want to 2:2, so 0.1, if you want to produce 0.1, 0.1 must have reacted. So they're gone. And to produce 0.1, 0.05, it's 2:1. So 0.05 must have reacted. ठीक है, remember ratio जो है ना वो इस पे apply करना है, बीच वाले पे. Initial moles, equilibrium moles, don't apply ratio on that. You found out that you added 0 and now you have 0.1. That means 0.1 got produced. So if 0.1 are getting, Haji.
Sir, can you repeat what you said? कि किस पे apply करना है the ratio method?
देखो ratio जो है ना वो initial के ऊपर apply नहीं करना है. Initial जो है वो आप container में ना जो मर्जी डाल दो in whatever ratio you like. Like you mix SO2, you mix O2, you mix SO3. That could be in any ratio. Is that clear?
Yes, sir.
So इनका जो भी ratio होगा ना that could be any ratio. मैं इसके 10 moles डालता हूँ SO3 के, doesn't matter, ठीक है. Equilibrium moles का भी ना कोई भी ratio हो सकता है. What is important is the reaction. I mean the ratio of 2:1:2 only applies to what reaction is happening. So we figured out कि कितने डाले थे शुरू में 0 SO3 था, there was no SO3, right? And now you have 0.1 moles. That means the reaction happened and 0.1 moles of SO3 got produced. इस पे रेशो अप्लाई करना है. So 0.1 moles of SO3 got produced during the process. Clear है?
Yes, sir.
तो अगर 0.1 प्रोड्यूस हो रहा है तो बीच वाले पे अप्लाई करना है. तो अगर 0.1 प्रोड्यूस हो रहा है तो अकॉर्डिंग टू द रेशियो, if you want to produce 2, one of this should react. So if you want to produce 0.1, 0.05 must react. आधा react होगा ना. 1O2 produces 2 SO3. So if you want to produce 0.1, 2:2. So that means if you want to produce 0.1 of SO2 must have reacted. Is that clear?
Yes, sir.
तो जो रेशियो वाला पार्ट है ना वो सिर्फ इस पे अप्लाई होगा. तब आ जाओ कि अगर स्टार्ट में you had 0.2 moles and 0.05 got reacted, so you're left with how much? क्या होगा? 1.15, right? And this one, at the start you had 0.2 moles and now 0.1 have reacted, so you're left with 0.1 moles. Is this clear?
Yes, sir.
तो आपके पास equilibrium moles आ गए. And remember कि you can't use moles in the expression, you have to use concentration. Concentration is moles over volume. The container volume is 1 dm cube. A lot of people miss this step. I said now 1 dm cube is pointless because divide everything by 1 dm cube, it would give you the same value. So, I mean, this step is, in this case, pointless, but you always have to remember, always do this step. Kck expression where you use concentration. What is the Kck expression? Kck expression would be it's going to be SO3 concentration divided by the reactant concentration. So it's going to be SO3 concentration, that's going to be squared, divided by SO2 concentration, that's going to be squared as well, into O2 concentration, right? So we've got 0.1 squared divided by what? 0.1 squared, and O2 is 1.15. Not 1.15, this is 0.15, sorry. 0.15, क्योंकि 0.2 था and 0.05 are gone. So that will give you 0.15. So this would be 0.15. तो अब इसका जो भी आंसर आ रहा है देख लो कि क्या आ रहा है. What do you get? किसी ने निकाला क्या आ रहा है? कौन सा ABCD में कौन सा? डायरेक्टली इधर से देख लेते हैं कि this is going to be 10. आवाज ही आ रही थी मुझे. 10 is D. So are you getting D 6.67 for this?
Yes.
Plus पे ये कर लेते हैं. Two reactions are shown. Equilibrium. A finely powdered iron catalyst is used. ठीक है, चलो fine. Reaction 2, a vaporized tetrachloromethane catalyst in ultraviolet light is used. चलो ठीक है. Which statement about the catalyst used is correct? अच्छा, question मुझे अभी से समझ आ गया कि if you use a solid iron catalyst, that is a heterogeneous catalyst. But if the catalyst has a different state, that's a heterogeneous catalyst. ये gas है and the catalyst is iron, that's solid. And if you use vaporized, that's also gas. The catalyst is vaporized form, that's gas. If they're in the same state, that's a homogeneous. That's a homogeneous catalyst. The question is इसी के ऊपर होगा क्या है पीछे options. बस वही है. Reaction 1 uses a heterogeneous catalyst, and reaction number 2 uses a homogeneous catalyst. That's going to be C. फिर अगला कि sodium and sulfur burned separately. Each reaction has a distinctive colored flame. So, which one is correct? मुझे खैर दोनों का याद नहीं है. इसके वो नोट्स देख लेना. फ्लेम कलर्स मुझे कभी भी याद नहीं हुए. कहाँ पे नोट्स? सल्फर का ब्लू होता है, सल्फर इज ब्लू, वो मुझे याद है। ठीक है, दिस वन सल्फर इज डेफिनेटली ब्लू। सोडियम शायद येलो होता है। लेट मी जस्ट क्विकली चेक हमारे नोट्स कहाँ पे, ये वही नोट्स है लाइक किधर है नोट्स, इनऑर्गेनिक। अच्छा, इस पे ना पीरियड 3 के एंड पे ना फ्लेम फ्लेम टेस्ट लिखे हुए हैं, ग्रुप 2 के एंड में भी फ्लेम टेस्ट लिखे हुए हैं। मेक श्योर यू मेमोराइज दीज। ये पहला पेज छोड़ के ना यहाँ पे लिखे हुए हैं। सोडियम इज ब्राइट येलो, हाँ ठीक है, और सल्फर जो है ना वो ब्लू था। हाँ, तो ये दोनों का फ्लेम टेस्ट है, ठीक है। तो इनका तो बैठ के रट्टा लगाओ। तो इस पे वापस आ जाते हैं। दैट्स इज मेमोराइजेशन, इट्स येलो एंड ब्लू। ठीक है, सी। Or you've got X and Y elements in period 3 of the periodic table. Oxide of X is a solid at room temperature. The oxide has a giant structure. There's only one oxide in period 3 that has a giant structure. The inorganic charge, only one. And that is this one, silicon. Silicon is macromolecular. Uska jo oxide hai, that is also macromolecular. अच्छा जी, एक और भी हो सकते हैं वैसे. Let me just go back to the question. The oxide acts as a solid. अच्छा, उससे ये वर्ड यूज नहीं किया, जायंट. इज इट अ जायंट कोवलेंट स्ट्रक्चर और जायंट आयोनिक स्ट्रक्चर? सो दिस कुड बी लॉट्स ऑफ एलिमेंट्स. अगर वो कोवलेंट यूज करता ना, दैट वुड हैव बीन. सो SI इज वन, SI इज पॉसिबल, sodium is also possible, magnesium is also possible, aluminium is also possible. क्योंकि उनके जो ऑक्साइड है ना वो जायंट आयोनिक होते हैं. इन तीनों के जो ऑक्साइड है ना, दे जायंट आयोनिक. SI is giant covalent. तो से ये बताया ही नहीं है कि is it a covalent or is it a, and they're all solids. ठीक है. बाकी नहीं हो सकता है. इसके अलावा जो बाकी ऑक्साइड्स है ना, that's not possible. क्योंकि phosphorus oxide is a simple molecule, sulfur oxide is a simple molecule. So chlorine and argon, they don't usually have oxides. तो लेकिन वो जाइंट कोवलेंट, वो जाइंट होते ही नहीं है. They're simple molecules, they're just tiny molecules. SO2 है जिस तरह, that's a small molecule. ये पहले चार के ना giant structures. So he didn't mention giant covalent, so that chloride of X does not react with water. So chloride does not react with water. So go back to the notes. Where's the reaction of chlorides with water? It does not react with water. Now you've got this option, NaCl. NaCl only dissolves, does not react with water. और कौन सा जो नहीं रिएक्ट करता? All of them react. AlCl3 reacts. MgCl2 has a slight hydrolysis. SSCl4, PCl3, PCl5. They all kind of react. पीछे रह गया मेरे ख्याल से Na रह गया. Its chloride does not react with water. NaCl does not react with water. तो फिर वो कह रहे हैं argon is the only element in period 3 with a lower melting point than Y. That also makes sense. तो कोई क्वेश्चन है? तो ये याद रखना कि इन नोट्स में पहले भी बनाया था, इसके ऊपर वो बना नहीं सकता. Na का मेल्टिंग पॉइंट इज वेरी लो एक्चुअली. ये यहाँ पे गलत है. जो उस पे बोर्ड के ऊपर जो नोट्स के बने उसमें मैंने एक करेक्शन की भी है. जो आईड्रू के बोर्ड के ऊपर नोट्स है जिसमें एक्सप्लेनेशन भी है सारी चीजों की. So Na has a pretty low melting point. चलो ठीक है. I'll actually मैं बता देता हूँ मैं कौन से नोट्स सेंड करूंगा. ठीक है, ग्रुप में. ये जो नोट्स है ना, ये वो है, ये बहुत कंसाइज है. ये भी सेंड कर देता हूँ. But I will send these ones inorganic. I'll send both. लेकिन ये जो व्हाइट बोर्ड वाले नोट्स है ना, इट्स द सेम नोट्स बट विद एक्सप्लेनेशन. ठीक है, यहाँ पे वो करेक्शन भी किया हुआ है. वो Na का मेल्टिंग पॉइंट एक्चुअली बहुत लो होता है. ठीक है, जैसे मैं बता. अच्छा, लेकिन यहाँ पे एक मसला हो गया. इसका आखिरी पार्ट क्या था क्वेश्चन का? अच्छा वो एक X था और एक Y था, तो क्लोरीन का मेल्टिंग पॉइंट बहुत लो है, तो NaCl, राइट? So it's going to be NaCl. So ठीक है, I'm going to send the notes and I'm going to send the board link as well. इसको
um,
लैपटॉप पे ओपन करना, क्योंकि ये उसी की सारों चीजों की ना एक्सप्लेनेशन भी है साथ साथ, ठीक है?
सर I want to ask something कि सर अगर आप ये ड्राइव पे पूरे AS के नोट्स अवेलेबल कर दें, ताकि we have one like one folder we can go through before exams.
ठीक है, वो मैं कर देता हूँ। मसला ये, मेरे पास वो एक फोल्डर है ही नहीं, तो मैं वो कर देता हूँ, मैं पहले बनाता हूँ एक फोल्डर, पे मैं उसको शेयर कर देता हूँ, ठीक है?
And sir for A2 also, मैं A2 की क्लास में भी आपको करना था।
ठीक है, ठीक है, ठीक है, चलो ठीक है।
अ,
मैं खुद वो बल्कि वेबसाइट में भी ऐड कर दूंगा। मैं उन सारे नोट्स को ना इकट्ठा करके बहुत सारी चीजें ना ऐसा बोर्ड के ऊपर भी है, तो मैं इवन बोर्ड लिंक्स ना शेयर कर दूंगा, ठीक है, उसके ऊपर।
yes sir, and sir one more thing कि सर आपने P5 मतलब आपके स्टूडेंट्स नहीं दे रहे हैं, as in I
हाँ
asked on the
वैसे
group and
नहीं, वैसे तो कोई भी नहीं दे रहा, बट वी कैन डू P5। P5 इतना मुश्किल नहीं है, P5 इज काइंड ऑफ इजी, विल डू। आपने ऑप्ट किया हुआ है
so sir
P5?
no sir not till yet, but यही I want to ask कि do you prefer P5 or not,
नहीं नहीं, P5 छोड़
like
दो,
कोई
क्योंकि
जरूर।
क्योंकि उसकी कोई इतनी वेटेज तो है नहीं।
ओके सर, क्योंकि सर देयर इज अ कंफ्यूजन कि वो लोग आई हर्ड समवेयर कि जब अगर आप दोनों ही नहीं दो एज इन P3 एंड P5 तो आपका प्रैक्टिकल पे ना वो उनके पास कोई एज एन एविडेंस नहीं होता आपको
नहीं
मार्क
नहीं,
करने के लिए, ना ही P5
वो ये कर
P5।
रहे वो ये कर रहे कि P3 का मार्क्स बताओ कैसा दे रहे हैं, कि P1 P2 के जिस बच्चे के मार्क्स आए होंगे ना आप जितने, ठीक है, तो वो उसका देखेंगे कि उसके P3 में कितने आए हुए हैं। तो उसका जो P3 की एवरेज होगी ना, जैसे आपके P1 और P2 में मिला के ना आउट ऑफ 100 आते हैं, 80% आते हैं। तो वो देखेंगे कि जिन बच्चों के 80% आए हुए ना P1 और P2 में, तो उनके जिन लोगों ने प्रैक्टिकल दिया है उनके प्रैक्टिकल्स में कितने आ रहे हैं, तो आपको उनकी एवरेज लग जाएगी। समझ आइए बात?
यस सर।
मतलब वो नहीं होगा कि आपको P1 P2 की एवरेज आपकी आगे नहीं जाएगी, वो देखेंगे कि जिन बच्चों ने एक्चुअली P3 दिया है ना, तो वो आपके देखेंगे कि आपका मैच करेंगे P1 P2 का कंबाइन करके ना, कि किसके साथ मैच कर रहा है, और उन बच्चों के P3 में कितने आ रहे हैं, तो वो वाले मार्क्स आपके ऐड हो जाएंगे।
ओके सर, थैंक यू।
हाँ ठीक है, वो 3 कर लेंगे नेक्स्ट टाइम, ठीक है? चले, ओके एवरीवन,